This is the second video in a series of 2 videos on the numberline or measurement model of addition and subtraction. Numberline and measurement used in this context mean the same thing. As we saw in the first video, which I will link in the description below, we are going to be using the model as it is set forth by Long, de Temple, and Millman, the authors of our textbook, Mathematical Reasoning for Elementary Teachers. We also saw in the first video that there are multiple different ways that teachers use a numberline model in their classroom, but we're going to follow this specific approach. One reason is that it's in our textbook. Another reason is that it's an excellent approach because it distinguishes between subtraction and negative, which are different things. And the nice thing about that is it helps students not only in arithmetic where they're working only with positive numbers, but if they learn this method of the numberline model, then they're going to be able to even carry this on into their pre-algebra and into their algebra work, because they'll be able to do things like subtracting with negative numbers without being confused about what that means. So this method is a little tougher than some others that teachers might use in their classroom, but it's well worth it. So stick with it, and the more you work with it, the more comfortable you will be. So we will be using the rules that were just on the screen. And for the first problem, we have 3 minus negative 2. So what I need to do is to represent the 3. I will use a right-facing arrow, and I will place that beginning at 0 and landing on 3. I've represented the number 3. Subtraction is head-to-head, and I'm going to be subtracting a negative 2. So what I need to do is to grab a representation of negative 2, which is a left-facing arrow, and I need to connect these head to head, in other words, arrow to arrow. Okay, so obviously you don't need to use transparencies in order to do this. I'm just using them because I like to be able to move them around, and I think it helps me to illustrate the concept better. But we could have just drawn that. We could have drawn an arrow from 0 to 3, and then we could have drawn another arrow 2 spaces long, but with the arrow pointing left instead. In the textbook, the authors will often draw in a third arrow that they call a resultant arrow. And that's really more helpful if you're working with division of positive and negative numbers. And that's something that we're going to shy away from. So I'm not going to expect to see this resultant arrow. But we do see that our result is 5. And that is the value of 3 minus negative 2. If you've learned this particular trick, this might make a lot of sense to you. Someone may have said, well, if you have minus negative, make them plus positive. Well, isn't 3 plus 2, in fact, equal to 5? And that's what we've just done, 3 minus negative 2. So I'm going to go ahead and move those off, and we will work with negative 5 plus 4. So I need a left-facing arrow representing negative 5. We start at 0 and place that there so that the arrow then is on negative 5. And I want to add 4. Now, addition is head to tail, and I'm adding a positive 4, so I need an arrow that is a length of 4, and it's pointing to the right because it's positive. It's addition, so I'm connecting head to tail, not 2 arrows together, but head to tail. And, oops, you have to be a little patient with this sticking to my fingers. That's one benefit of drawing it instead of using transparencies. But where this ends up, our resultant is negative 1. So negative 5 plus positive 4 lands us on negative 1. Moving on to the next example, we have negative 2 plus negative 5. So I need both of those arrows, both pointing to the left. We start on 0 with negative 2. And because we are adding, we hook head to tail. So arrow to non-arrow. So here we go. And we see that negative 2 plus negative 5 results in negative 7. Oh, I'm having trouble with my transparencies moving around, but you can see that we're over here on negative 7 when we finish, and it is the case that negative 2 plus negative 5 is equal to negative 7. So our last example is a subtraction problem. So we will be connecting head to head because that is our definition of subtraction. We start with the negative 5. So there's our negative 5. And then I need to subtract a positive 3. This is subtraction. It is not negative, so we're hooking head to head. And I need a positive 3, which means that I have an arrow that is pointing to the right. Let's move this up a little bit. Okay, so there's our negative 5. We're going to subtract a positive 3. Subtraction is head to head, so I put the arrows together, and we find that negative 5 minus 3 is equal to negative 8. If you need some further background with this, do be sure to look at the first video, which is linked in the description below.